Hello everyone, my name is Kelvin, and today I would like to discuss the last lab of Physics 1, which is lab 5, about the Angry Bird projectile. So if you guys remember our lab 2, we also did a projectile motion on the whiteboard eraser, so you guys might be very familiar about this. So for the content table of today, first of all, we will of course introduce the purpose of Lab 5 and then talk about some basic theories you guys must be very familiar of after taking the Physics 1 class. And then I'll talk about the procedures of today's practical plan. And then the procedure includes video production using the Angry Bird game, and then the tracker analysis and calibration, and then also using GlowScript to produce a computational model. And then lastly, I'll do some data analysis, including the graph comparison, potential errors, and also some further discussions of some very interesting questions you guys might wonder. First of all, what is the purpose of Lab 5? So the purpose of Lab 5 is to observe a projectile motion, and then we also use the Newton's second law to analyze it and compare it with a computational model. So the object is the flying Angry Bird, and then the observed motion, we can use tracker to calibrate it, and then use a GlowScript to do coding to produce a predicted motion. So the second thing is about a basic theory. So first of all, the basic theory includes the Newton's second law, which is also the momentum principle. And then we can use the momentum principle to derive the velocity update formula in the iteration later we will use in the code. You can see all the derived in the bottom part. I have handwritten all the notes. Second thing is gravitational force, which is literally just negative mg in the y-axis in the vector. And then finally is the air resistance, but for convenience in today's model, we'll just omit all the drag force. So the next thing is about the procedure of the practical plan. First of all, we will do some observation by use a screen recording of our iPhone and record a gameplay of the Angry Bird projection. And then the projectile motion will be calibrated using a tracker, and then we collect the experimental data, and then we also use a GlowScript to model theoretical motion, and then we'll finally compare the two graphs, the two results, and then we'll do some further discussions while also talking about some potential error. So now I'm going to talk about my practical. First of all is the motion observation. As you can see, we play a kind of Angry Bird game, and then in the right side is the X and Y axis. And then we also remember to insert all of the the initial condition, except for example, the mass of the Angry Bird is 3 kilograms, very heavy. And then you can see the X graph is basically almost a gradient, like a constant gradient. So it actually matches the constant X direction velocity because there are no drag force. And then the Y displacement is basically just a projectile motion, like a quadratic curve. And then second part is the coding. So remember to insert all of the initial conditions you find in the tracker analysis and then insert it inside. So the thing you have to be careful of is the gravity. So the gravity in the game is actually not 9.8, but later we'll explain it. So lastly, we'll do some data analysis. First of all is the position time graph. So as you can see, the experimental graph is the blue one, and then the GlowScript, which is the theoretical one, is the orange one. You can see the GlowScript one, although it's kind of matching this at the start and final position, but in the middle part, especially the maximum height, there's a big difference. So as we have mentioned before, it might be the gravity constant we put, because we put 7.4, right? So it might be affected. And then the possible errors include there might be other force like the wind blow, and then also there might be other drag force. And then the rounding errors can also causes the calculation mistakes. So because we use 2 decimal places, so actually it can cause a bit of difference. And then lastly is the planet gravity, because the gravity of the Angry Bird planet is different from Earth, so we cannot use 9.8. And then now we're going to discuss some further questions. First of all is a comparison of different gravities of Angry Bird planet. If we use a larger gravity, as you can see, the maximum height will be lower. It's because of V in the y-axis is equals to Vi minus F net over M, and F net equals to negative mg, right? And then, so we have a minus sign in the first, and then times delta t. So actually, if the g is larger, it will decrease the speed more, so the maximum height will reduce. And then also we know that the mass of the Angry Bird is independent from their velocity and also displacement. So there will be no difference even we use a heavier bluebird or a lighter token bird. Yeah, and that's all my presentation. Thank you very much. I hope you guys enjoy my labs and then also enjoy 361 class. Good luck on your final and midterm. Bye bye.